Okay, welcome back to Pre-Calc Notes 2.7. So we left off discussing where or what x values we're going to test in each of the zones. So let's start by doing that. So we said if x was -2, if we plug that in, we're going to get -2 times -2 squared plus 6 times -2 plus 15 has to be less than or equal to 0. And so if we go through and we do the math with that, we end up getting -5. And I know that -5 is less than 0, so that's true. So I'm going to want to shade in that zone. Picking the number in between in zone 2, we use 0. That's pretty easy. If I put zeros in for both of these, you would just get 15 is less than or equal to 0. So again, that's me plugging zeros in here. That's going to make all of that become 0. And that's false. 15 is not less than or equal to 0. And then in the last one, if we put a 5 in to our x value, or in for our x value, you end up getting -5 again. And we know that -5 is less than or equal to 0, so that's true. So we can shade everything in this zone, everything in this zone. And because our problem can be less than or equal to, we know we're going to put brackets, and the brackets will face this way. One will face that way, and one will face this way at those values. Now when I write my answer in interval notation, remember this is -infinity, and this is positive infinity. We're going to say from -infinity, comma, -3 plus the square root of 39 over -2, bracket. And then or, bracket again, -3 minus the square root of 39 over -2, comma, positive infinity, and a parenthesis. And so that would be our answer in interval notation. So our next example is now trying to solve a rational inequality, not a polynomial anymore. So when you have a rational expression like this, what you need to do is find the zeros for both the numerator and the denominator. So set your numerator equal to 0, set your denominator equal to 0. So we end up getting our critical numbers as -5 and +3. So if we put those on our number line. Now the thing that we have to be aware of when we have these rational inequalities is that if you were to go back and put a 3 in here, that's going to make this be undefined. So right away we know that our problem cannot be equal to 3. But since our inequality sign is a less than anyways, we know that it's not going to be equal to either one of these. But if I had changed the problem to make it be less than or equal to, I wouldn't be able to put brackets at both of these because I know that at 3 my problem becomes undefined. So be careful when you have the inequality sign that is less than or equal to or greater than or equal to. You can't always use parentheses when you have brackets when you have the rational expression. And that's going to come into play actually on our next example, so I'll get back to that point again. For this one it doesn't really matter because of the fact that it's not equal to 0 anyways. So this is going to divide us up into 3 test zones, 1, 2, and 3. So for the first zone, I'm going to use, let's say -6. The middle zone, I'll use 0. And the last zone, I'll use 4. So if we plug in -6 plus 5 over -6 minus 3, I end up getting -1 over -9, which is 1/9. And 1/9 is not less than 0, so that's false. So I don't shade there. Let's try test zone with 0 there. 0 plus 5, 0 minus 3. I get -5/3. And I know that that is less than 0, so that's true. So I'm going to shade the middle area. And then finally with test zone 3, if I use x equals 4, 4 plus 5 over 4 minus 3, that's 9 over 1. I know 9 is not less than 0, that's false, so I don't shade that. And again, because I'm not equal to, I'm going to put parentheses on my number line, and they're going to have to face inward like that. So writing my answer in interval notation becomes pretty easy. Negative 5 comma 3 with parentheses around it. Now this next example again is another rational expression. It's not greater than or equal to 0. This time it's greater than or equal to 3, so I need to move the 3 over before I can find the zeros of the numerator and the denominator. So it'd be x plus 12 over x plus 2 minus 3 is greater than or equal to 0. Next issue we have to deal with is subtracting fractions. So what I want to do is I want to make this fraction have an x plus 2 as its denominator. This one already does, so that one's fine. And so the only way that I can make negative 3 have an x plus 2 in its denominator is if I multiply it by x plus 2. So it would end up becoming 3x plus 6. I'm going to put parentheses around that, so I remember I have to subtract both of those terms. So when I write my problem now as one denominator, I'm going to do x minus 3x, which is negative 2x. And 12 minus 6 is going to be a positive 6. Okay, so now that I've got it to be a rational expression that is, in this case, greater than or equal to 0, now I can set both my numerator and my denominator equal to 0 and solve for the critical values. Oops. Should be equal to. So here I'm going to get, if I subtract 6 and divide by negative 2, I get 3. And here I get negative 2. So let me put those numbers on my number line. Negative 2 and 3. Again, let me go back to the point I was making in the previous video. I know that if I was to plug a negative 2 in here for x, I put negative 2 in there, this is going to become undefined. So I know that I cannot, my value cannot equal negative 2. So I know x can't equal negative 2, so I'm going to have to put a parenthesis there. I just don't know which way I'm going to put that until I start to shade. Now with 3, if I plug 3 into here, this is going to give me 0 in the numerator and 5 in the denominator, so 0 divided by 5 is going to be 0, so that becomes a true statement. So at 3, it can be equal to, so at 3, I'm going to use a parenthesis. And this is where it can get kind of confusing, because one of the values I'm going to use a parenthesis, and one I'm going to use a bracket. But that's because of the fact that this is a rational expression, and my problem will become undefined if I use an x value of negative 2. So let's keep that in mind when we go back later and shade our graph. Okay, let's divide it up into test zones, 1, 2, and 3. Let's use negative 3. Let's use x equals 0, and let's use x equals 4. So if I use negative 3, it's going to be negative 3 plus 12 over negative 3 plus 2, and that has to be greater than or equal to 3. It's a plus sign here. So that's 9 over negative 1. Negative 9 is not greater than or equal to 3, so that's false, so I don't shade there. If I put 0 in there, this becomes pretty easy on this side. It's 12 over 2. Is that greater than or equal to 3? 6 is greater than or equal to 3, so that's true. So I'm going to shade in the middle there. And then if I use an x of 4, 4 plus 12 over 4 plus 2, is that greater than or equal to 3? 16 over 6. 16 over 6 is going to be 2 2/3, and that is not greater than 3, so that's false, so I don't shade there. And again, remember how I wrote this up here. This is going to be important. I now know that I put a parenthesis at negative 2 because it can't equal negative 2, but it can equal 3. So it's important that you test the critical values Otherwise, we would have both of these being parentheses because we'd look at this sign and say, yep, they can be equal to. So you have to remember when you have a rational expression like this that sometimes your denominator is going to become undefined when you put a certain value in there. And that's going to be the value that makes your problem equal to 0. So my final answer for this would be parenthesis -2 comma 3 with a bracket. And the number one way that I would see students getting this wrong is you would have a bracket here because you would say, oh, it can be equal to, so both of my numbers get brackets. Don't forget this important part about testing the critical values when it's a rational expression. You don't really have to do it if it's just a polynomial, because you're not going to get that 0 in the denominator, which makes your problem undefined. But you will need to do it when you have this rational expression. So always take the time to test those critical values.